Initially, we are with a new number guessing game. So the number guessing game means, so we have a number, and that number, we will have one as a lucky number. The user should guess that number. So for that, we have written a small code. So the given number is equal to integer of so and so. It will take an integer. If the number is equal to the lucky number, we say true. You guessed correctly. If not, we say like increase or decrease your guessing number. That's the whole motto of this program. So how to execute it? We need to navigate to this directory. So either right click, copy the path, go to this directory. And it's not mandatory that we should go to the directory every time, but it's a best practice. So if I go here, Python space, you see now, it is asking for a number. I gave like 23. It is asking to increase your guessing number, 34. Okay, so I ran it again, say 34 again. It is saying to increase your guessing number. Again I ran it, I gave like 45. Increase your guessing number. Again I ran it like 56. Increase your guessing number. If I say like 67, so finally I could make it. But in how many choices I took, how many attempts I made, that also makes a difference. And in this option, so we can do without any number of limits. We cannot give a particular limit to the user that, hey, you need to go for this much number of times. If you want to enforce that kind of limit, so then we need to take this entire options into a while loop. So for that, like we need to have one while loop to execute. So for that, I can take a variable called as attempt. So which would be the value of 0. And while attempt is less than 5, so every time like attempt plus equal to 1. So this is what a while loop I made. So the entire logic above, I want to place within it. So if I do like this, then see here, my entire logic will come under it. So this would be like a method 2. So now I have a limit. So how many times it will execute? You see now. If I clear the screen, if I execute again, first I gave some 23 again, 34 again, 45 again, so 55 again, 56 again. So what it is saying? Hey, increase your guessing number or so based upon the values. But after then, it stopped. Means for each of the attempt, it is going. And once the attempts were reached, it is stopping. So you can understand that, now we can enforce this kind of limit, that how many times you want the user to do. Okay, so suddenly it abruptly stopped. But how can we know that, the program stopped because of no valid attempts? We should mention, right? That's what the thing. So to do that, so in this particular example, what I can say is that after all my conditions were done, I can say like, hey, if attempt is equal to 5, means in the last I want to print something, right? If all the attempts were done, but still user cannot achieve something, in the last I need to do. So I gave an if condition. See, this if else is like a one related case. This is an independent if condition. It is nothing to do with the number, right? If the attempt is equal to 5, then I want to print that, hey, sorry, you increased all your used all your attempts, but you couldn't address it. Like that I want to print. Now you see this time, if I execute, within the same execution, you give like 34 again, 44 again, 55 again, 56 again. So what happened right now? Over a period of time, if you are able to achieve, it's okay. If you cannot achieve, it is saying that, sorry, you failed in all your attempts. Now it is more clear, right? As an individual, so if something fails also, any person is okay. But user should be aware of why it is failing. Else it would be a confusion, right? Okay. In this process, you can understand that 5 times this loop is executing. because we have given 0 to 5. And every time this condition will check. But don't you know that, attempt will equal to be 5 only in the last case? Till then, this condition is not needed, right? And in general, if you write one condition, the condition also will take some moment. So 5 times this condition should check means, just imagine like how much memory it will take. If you have a scenario in this way, where a particular condition will execute only at the end of the last loop, in that case, we can go for one kind of optimization. For that, there is a concept called as, in a while loop also, we can have an else condition. What is this else condition for a while loop means? I will repeat the same thing. I will comment it, and you see here. So instead of you writing this condition entirely here, I write a else condition here. So I need not write this again, attempt is equal to 5 or so and so. So why I need not write, I will tell. So when attempt equal to 0 till 5, every time it will execute, right? So every time when it is executing, so till the 5 executions, it will execute. In the last execution, it will come out. In the last execution, when it came out, then if you want to execute something, so that's where you write the else. So you see now, in this case, it will execute. So yeah, so I can say like, you failed it. Okay, this is the thing. So now example, see here, the same example I'm repeating. 22, same 23 I'm repeating all the times. You see what happened? Same like in the previous case, it also worked again. But one optimization, what is that? Is that generally any beginner who come to Python as a language will be confused. Till now, everyone knows that there will be else condition for an if. If the if condition is not correct, else will execute, right? That's what we are learning till now. But there will be a else condition for loop or while loop also. This is something very new for the people who are coming to Python. What is the else for a while loop means? Very simple. If the while loop is designed to execute for n number of times, in this case, it is designed to execute for 5 times. If all the 5 times it executed, in the last after last thing, this else will execute. It's a very simple thing. If you write like I equal to 0, I equal to 0, so I less than, sorry, while I less than 5, I plus equal to 1. Very simple logic. You print like what is the value of I. And finally, you write a else condition. So while else condition, you write a small logic like this. Okay, ignore for this for a moment. So I commented. You can see if I clear the screen and run again. Did you see what happened? So what are the logic it executes? In the last while else condition was executed, right? Means how many times it is designed to execute, those many times it executes. After the end of all your loops, this else will execute. Sir, in which condition this else will not execute? I will tell you shortly. So before going there, so now you understood this problem. So we have solved one problem here, but there is one problem I didn't tell till now. Let's execute this. I gave like 23, okay, 23, 23, 23, 23. You understood that you couldn't solve in the 5 attempts. It failed. Let me repeat again. So this time I gave 67 directly. In the first attempt itself, I was correct. See, if you are correct, you are given 5 attempts. In these 5 attempts, you need to be successful. In the first attempt itself, I am successful, but still it is asking me the values. This is not correct, right? I am correct. I am correct. I am correct, but still it is asking. So what is the reason for it? To address this problem, we need to understand one thing. If you are part of a loop and if you want to break it, why this problem is occurring is that whether you are successful or not, it is printing and it is again going to the next loop. To avoid that, whenever these things were correct, we need to use a keyword called as break. What is this keyword called break means? It will break the current while loop. While or for loop, any loop, it will break. The concept of loop, this itself is the same. Now we see what will happen. If I give some 23, it will say like increase your guess or decrease your guess. But if I give 67, so then the value will be equal to this. It will enter this condition and it will break the loop. And one interesting point you can observe is that whenever the code was broken, so did you see that the last statement is not executing? Now, 2 points you need to understand is that else is the statement which will execute after all the while loops were executed. If it was broken in middle, how a while loop will be broken? If you use a break statement. When it will be broken? If you give the value correctly. So guess it correctly, it will break, right? So the moment you use the break, it will break the current while loop. So we understood now clearly entire solution. If I execute again, if I give 23, it says increase your guess. If I give 45, increase your guess. If I give like 56, increase your guess. So if I give like 67, it will say you guessed it correctly. So whether it is the last option or any number of option, so last attempt or any number of attempt, I attempted it. So if it breaks the loop, so that's it. So it will not execute the else. Else will execute if nowhere the break was encountered and it was executing all the loops it is designed to execute. Hope it's clear. Now going further. So like this, while and execute, it is fine. Okay, here in this case, we have a fixed amount of limit, but we don't have like a liberty, like, how many loops you want to do. Means like attempts is not flexible enough. The attempts is fixed here. But if you want these attempts also to be like agile, so you want to make your own number of attempts. So then we need to go with another option. So for that, what I will do is like, I would go with another option. So you see here. So same like this option. Here we have attempts, right? But we are making a condition based upon the attempts. But I will make one more thing. There is one thing called as choice. I create a variable called as choice and I give the value as say some y. So and for attempt also, before going there, so how I do it, like, if choice equal to y, so then like you continue. So within that, like entire your logic will happen, and within for the first time it will be executing. Afterwards, you write a condition that hey, choice is equal to input of. You ask the user. The user will give y or yes. So based upon that, you get it. So every time it will repeat. Every time it will repeat. If the choice is so and so, then it will execute. Till then, it will execute. Okay. In the process, how many times user is giving yes or no? So those many times you want to repeat. Then we can go. So if you just want to do this condition, I can take it and I place it. So, okay. Anyhow, for the first time the user enters, you want to execute, right? You give it. After the execution, you want to do. So, okay, I commit like this. You see now? So how many times user want to execute? Those many times now things will execute. You see now, clear. If I execute say 23, say increase your guess. Enter to continue. Yes. If I say yes, it will ask. 45 give. Yes to continue. If I give like 56, yes to continue. If I give like 66, yes to continue. If I give like I don't give yes, if I give something else, it will stop. Or even in this case also, if I give correctly, it will be good. Same logic. But here it is not limited to 5 attempts. It is not limited to any specific number of attempts. We got the flexibility. All good, sir, but like we don't know how many attempts were done, right? If you want to make a track of the attempts, then in this case also, we can have the attempt variable. So we can have attempt variable is equal to 0. And like every time we can increase the attempt value, say like, attempt plus equal to 1. But condition is not based upon the attempt. Earlier we have condition based on attempt. Now we are not making condition based upon attempt. And if you want, in addition, if you want to print also, you can print the attempt value. I can do like this. You see, I did a slash n every time, means new line it will print, and end is like colon, means after printing it will print this one. So hope you know, right? So what all things we can do with the print statement. So if I execute right now again, you see every time when it is printing, it will print the attempt, and as end is equal to colon instead of new line, the next line also comes here together. So attempt 1, if I give like 23, yes to continue. So attempt 2, 45, enter to continue. So yes. 55, yes to continue. So again 55, yes to continue. So 55, yes to continue. You see now the limit is not there to 5. Any number of limits I can do. If suddenly I was successful, it is doing. In this way, now I made a track of both the attempts which were being done. So, okay, if all the attempts were not successful, then obviously we want to, print, right? Means like, if let's say you are not doing something correctly, in the else condition, here also we can write an else. You see, here also I want to make an else. So means you write every time the conditions, but finally if you didn't guess, so then also it should answer, right? Say 23, say yes, continue. So 34, yes, continue. Say again 34, yes, continue. I didn't do yes. If I don't do yes, it will stop the loop. When it is stopping the loop, in that case also I want to print, right? That's the reason I added this else again. And one more automation I can do is like, if we have two variables, so like this kind of assignment anytime, we can do an automation. We can do what? Instead of writing these two together in two separate lines, we can write in a single line like this. This is called as tuple unpacking. You write like y and 0 together in the single line instead of writing in two lines. Whenever you have two variables coming like that, we can do like this. Don't get confused. Very simple logic. So this is how it works. Now we had a stable, good solution like this. And also one more point. So here logic is good. The game is very good. But still, every time user need to say like, why, right? They feel they want to continue. Rather, why do you want to hold the every time with the user? Let them do any number of times. Finally, based upon the number of times they did, we can tell, right? So how many attempts they have did it. If you want like that, so you need not have this concept of choice at all. You can just do based upon these attempts itself. Means you have a attempt number. So we need to have a condition to go inside, right? So instead of going for some condition or the other, you need not worry about any condition. In Python, if you defaultly want to go inside, there is something called as while true. While true means it will be every time true, means anyone can enter this condition. So like this also we can write. So you have the entire logic as it is. Attempts we are increasing, what are the logic we have, everything we can write. But whenever you have this kind of infinite condition, means while true means like, so anyone can enter, right? There is no specific condition. In those cases, In those cases, we should not go to the else, because else code will not be reachable. Because if the code is like this while true, somewhere there should be a break to come out of the loop. So until there is a break, it will not come out of this while loop. So whenever there is a break, then else condition will not be executed. So that is what we should be aware of. Else condition will not be reachable if the while true is there. This is one thing. If I comment these particular things, what are we learned till now? So, and if we execute this, in this particular case, you have attempt equal to 0. Every time we are making a track of the attempts, and infinite number of times we are executing. Once the user gives the perfect answer only, it will enter. So if I execute right now, if I repeat again, if I say, now I need not worry about the attempts. So it should not ask this condition, right? Let me remove it. The choice is no one needed. Cancel it. Clear. Run again. 23, 23. So I need not worry. I can give for any number of attempts. So finally, in 12th attempt, I have successful. So this is a perfect game that we have created. So where now in the process, we learned a lot of things in terms of while, how to use the while loop, what are the various changes we can do, and all these things. Now for this, a small assignment from your side is that add some kind of, so points. Means if the user has completed in these many attempts, what is this? In user has completed in these many attempts, then what is this? Where should we write this condition? Will you write in else? No, because else is not reachable. Then in where you need to write? Here. Where before doing the code break, there itself we need to write. So you check the number of attempts there, and based upon the number of attempts, you write this entire condition here. So modify this such that we can understand. Hope it's clear. Similarly, in the same lines, let me write a couple of other logics and we can go ahead. If I go further, we can have something called as half diamond. Half diamond means like we need to create a diamond actually. So diamond based upon asterisk actually. If you want to create a diamond, how we can do? So I would say, like, if you want to learn more about logic building, these kind of problem solvings can help you better. So if I want to create a diamond, so what is a diamond actually? So diamond means the symbol will be like this. So later on, I will give an assignment of a full diamond, but like diamond will be typically like this. In this, if you want to create a half diamond or like a quarter of this diamond, then how to do? So we need to anticipate. Okay, so initially the value should be 0. Over a period of time, the value should increase, right? And in this process also, initially there will be more white spaces and one asterisk. Over a period of time, white spaces will reduce and asterisks will increase. So this is what a typical thing of a diamond. So how do you implement it? So first, try to generate the values first. Say for numbering, say range of 0 to say 10 with a step of 1. If I have, means what? I generate values from 0 through so and so. If I print the values, say print of number, if I execute again, clear and Python half time. First I am able to generate the numbers. So in Python, we can do a string string repetition operation. Means for an integer, we can multiply a string. If the string is having an asterisk, you see now the charm how it becomes. If I execute again, for every number it is multiplying. If you want to see both the results side by side, you can see that. If I see both the results, you can understand. 0, 0 times, 1, 1 time, 2, 2 times, 3, 3 times. So how many times the number is, those many times you are getting right. 1, 1 times, 2, 2 times, 3, 3 times. So how many times the number is, those many times you are getting right. So how many times the number is, those many times you are getting right. So how many times the number is, those many times you are getting right. So So don't you think in this way we have created a string repetition operation and we got the value, right? So this is a string repetition operation concept. In the same lines, we have created this half, right? This is easiest half, the right side half. In the left side half also we need to create. To create the left side half, also I will do. Before that, so in the right side only, below downwards we will do. This is kind of ascending. We have generated values from 0 through 9. Just think in the same lines. If you want to create the values in a reverse order, say from 9 to 0 if you want to create. How to do? Using the same range we can do for number in so range of, so now 10 till 0 you want to get. So, and if you want to from 10 to 0, we need to give a -1. That should be the step. And if I generate the numbers, if I execute, you can see the numbers are from 10 so and so till this one. And for these numbers, if I say like, so number into star. So did you notice? So don't you think that this is the sequence that you are expecting? You want like this only, right? You finally got what you expect. This is a half triangle which you got. So because like 10 is like a 2 digits, that's why you got like that. But typically this is how it is. Okay, half diamond you understood. Now the remaining half if I want to do. Remaining half means the first half. The first half needs white spaces first. Now to address this, first in the first half means like ascending, as you know. The second half means like descending. You know this sequence. Let's take the first half. In the first half, if you print again, you get the same values. Again the ascending order you get it. Again ascending order you get it. But you want things in a slightly different way. Means in the initially, let's say there are 10 spaces or 8 spaces, something. In all the spaces, everything is space, one character. Means as the numbers increases, the number of asterisks will increase, the total white space will decrease. So if I imagine like the total value is something, say 9, the value should be like that. If I say like 9 minus this number, whatsoever I have, so into this white space, if I do white space plus this star into so and so. Now, if I do this extra thing, you will understand the difference. Means in the total value, so 9 minus, why 9? I have taken 9 as a width. Based upon that, I am doing. If I add this one, that's it. It will give the asterisk white spaces followed by this thing. Now, in the same lines, if I go to the next half also, the same thing works. If I go ahead and do it, you see. So here also the same thing, the same formula I need to repeat. If I copy again and do it, execute, you see both the halves. So if I have like all these halves, I need to create the complete full diamond. So I would give that as an assignment for you and we can stop. Okay. And how we have achieved the same thing in a for loop. In the same fashion, let's try doing the same thing in a while loop. How to achieve the same thing using a while loop? So using while loop. So over a period of time, you should not be, incomfortable with one compared to the other. As a developer, you should be comfortable with both kinds of things. In while loop, we don't have something like a range. So we need to develop everything on our own. So we should be very careful in how we are choosing the options. In the first case, you want to go from 0 through 10 with a step of 1. The same thing you can do here. So I equal to 0. Why I every time? You can take any option for that matter. Just I is like most common people use. That's I using. So while I less than 10, I plus equal to 1. So what we do in this logic, I am just implementing using a while loop. And within that, whatever you print, the same print statement I am doing here. Same print statement I am doing here. You see now, it will execute the same way. So, okay. So what's happening here? We are getting every time the value to be equal to 1. So why the value is 1? Because you're checking for number, not I. So if I multiply with I, then you will get it. So now it's fine. You got the value to be like that. Similarly, if I want to do the same thing for, so now again, reverse. So from 10, if I want to go to 1, how do I go? So from 10, if I want to go to 1, you know what is the existing value of I? Because it will break when I is equal to 10 only, right? So anyhow, the value of 10 is so and so. But if I say like, I equal to 10, so while I greater than 0, so when the I is equal to 10 and you want to go towards 0, this should minus, right? Minus equal to 1. If I do plus here, it will go to infinite loop. So that's why you should be careful. And you can print it. So during the process, I can take this value. So whatever I have, I can multiply the same thing, right? I can do the same. You see now what will happen. You got I condition from 0 through 10. So sorry, till minus 1, right? You need to go till 0 with step of minus 1, fine. But I should get the values. Why I'm not getting? So let me write a empty print such that I will get a difference between these two. If I repeat again, you see now? Yeah, now I got clearly. I was confused with something else. So using while loop, you got like these two loops. Similarly, these two also we can get using the same while loop. So how we can get it? You can repeat the same logic. So why every time, I only? We can repeat with a j also as a wish. So whatever. If let's say this time I'm taking j is equal to 0. So while j less than say 10, as I mentioned, so j plus equal to 1 because we need to increment it. Fine. And here in this condition, what you want to achieve? Number minus so and so and so and so, right? So print of so j comma 9 minus j into white space plus this j into star. If I do right now, you can notice it. See how it's generating the values. But okay, you see here, now it generated the values. This is what exactly we are expecting. In the same fashion, in the diminishing range. So this j is equal to 10. So while j greater than 0, you need to write how the logic we need to make. If you don't want less than 0, then we should write greater than. So minus equal to 1. And in the process, we need to take this option and print it again. If I do again, you can notice it. So all the values are coming. In these options, if I remove all the numbers, you can see exactly the settings. Now, one assignment for you based upon these things is try to do the full diamond problem. So it's not that difficult. We can do the full diamond also in a very simple way. In fact, I have a solution, but I don't want to give to you. Lastly, before going ahead, the last point in the loops that I want to mention is the in loops, every time, whether it is a for loop or while loop, the 4 important things that we need to learn is about there are 4 conditions called as break, continue, pass, and sys.exit. What are these? how they can help me. So break, continue, pass are for different purposes. Let me explain you in a simple example. So I think like you can understand for loops anyhow. So let me try with a while loop. Then you will remember better. So I is equal to 0 while say I less than some 10, as you know. I plus equal to 1. Okay, I wrote a small logic. And after that, like I am printing, hey, I. If I print I, then what will happen? Okay, it's clear and Python I so and so. If I execute, I got all the numbers. Say like, I want all the numbers comma in the same line. I can do end is equal to like this, comma also, or white space as a wish. I get all the values in the same place. So if this is like a typical while loop, it was destined to execute for all the 10 times it executed. That's for clear. Now, if you want to know the importance of break, I take the same while loop and do something smart. So to understand the importance of this one, so I take the same loop and I place one condition. The condition is that, if every time I want to increment everything fine, but if I percentile 2 is equal to 0, I want to break. I percentile 2 is equal to 0, I want to break. When percentile 2 will be equal to 0? When it is a even number. So when it is an even number, you want to break. Now, did you see what happened? After 1, it was broken. Means only one value came. After that, it was broken. So whys are like this. So I write any condition for that matter. Till that condition, things will work. Let me give you one more condition. Say like, I is equal to 5. If I write I is equal to 5. Now you see here, till I is equal to 4, everything is executing. So the moment I become 5, it stopped. It came out of the loop. So if I write like, next statement, something like a next statement, it will execute. Means break will let you come out of the current for loop or while loop only. Now, to understand more the importance of the, continue, I will take the same example, but slightly do a modification. Take the same example. Instead of a break, I will write a continue. If you see the case of continue, did you see what happened? So whenever I is equal to 5, it is not coming in the output. Means that the next line will be skipped. So continue will skip the current loop. Skip next lines in current loop. Next lines means in this case only one line is there. So whenever continue is encountered, the remaining lines in the loop will be skipped and it will go to the next one. Okay. To understand more about this importance of this continue, let me give one more example. As it is equal to 5, things didn't work, right? Let me write like, percentile 2 is equal to 0. Percentile 2, when it will be for even numbers, it will be 0, right? So whenever you got even numbers, you want to continue means skip. Now we see what will happen. Whenever you got even numbers, you are skipping. Means, so it is printing only the odd numbers. The moment an even number comes, it is not going to the next line. Is it clear? Any doubt? Fine. Okay. So in the same lines, if you want to know the importance of the pass, which is the next statement, I will take the same example, whatsoever we have. Instead of a continue, I will replace with pass. What is a pass? Pass is like a placeholder basically. Means it will not do anything. Anything means anything. Then why that statements are means, if you want a condition, if let's say this condition should be there, if condition, if I don't write anything, so someone told me that, hey, develop this code, we need to have this condition. I don't know what logic to test in that condition, but we need to have a condition. So if I execute like this, it will throw an error. Hey, what logic you wrote? To make the syntax correct, so we need to have the pass. So whether you have a pass statement, that condition, or like if you comment this also, it makes no difference. So pass is like a placeholder basically. It acts as a placeholder for any of the logics. So pass is something not just used in a loops. So down the line, you will see a class, empty function. Wherever you want some syntax to be there, we use pass. Pass acts as a literally a placeholder for something you want to do. So if you want to understand further about the another thing called as sys.exit, there is one more option called as sys.exit. So to understand that, there is a module called as sys. Of course, we are using it for quite some time for small use cases. This is one such use case.
Sir, I have a quick question.
Yes, please.
So what is the point to put the pass on there? Because if it is not doing anything, like it just.
Yeah, it's a good question. I'm telling right just now that, say someone told you that, hey, you need to develop a code for the engine. Let's say there is a train engine. For the train engine, you need to develop a module. So whenever the train engine value is something greater than some value, you need to have a test condition. But like, I don't know what logic to execute, but you need to have that kind of condition. If someone says, means you need to have some if condition. So, but you don't know what logic to execute. You cannot just place a condition and write anything, right? If that condition should be there, so we need to do like this. Not only this, for that matter, like down the line, if you want to create a empty class, you write like empty my class pass, or a empty if condition, or like empty function define my func pass. Means wherever you want a structure to be, Python code structure should be there. In fact, it may not do anything, but down the line, if you want to add, in developers language, we call something like a to do. Hope you remember, developers write something called as to dos. Means like something that they need to do. I would say these are like a placeholder for the developers.
Okay.
It will not make anything. It will make the code structure ready. That's it. Okay.
Yes, sir.
Okay. Any other doubt? Sure then. Thank you. Now, finally, going for the last option. There is something called a sys.exit. To understand the sys.exit, it is same like the break. So why I'm telling break? Because I will tell you. What is the job of a break? To break out of a loop. Whether it is a for loop or a while loop, any one loop if it is part of, it will break that loop. Same like break, there is something called as sys.exit. This is also used for breaking. And when breaking, there is something called as 0 or 1. I told you like in general programming notion, we have a concept called as, zero exit or non-zero exit. It is nothing to do with Python. So generally zero exit means like successful or normal termination. Non-zero means abnormal termination. So you can write like 34, 54, any number you can write. But generally this is a common thought. So when you exit anything also, no one will take from it. There are certain times, so one process output will be input of another process. So in those cases, this number that which is the exit number will be taken by that. So generally, if you are typically writing a Python code, it may not be that different. But down the line, you will learn about something called as Airflow and a lot of other tools where one program output will be input to another program like that. That's where they make some sense. But for now, you can understand that sys.exit 0 means like, say, I told a simple example. You write a code for like, Facebook friends accept, friend request accept. Today, suddenly, when you have seen there were no more friend requests to you, then there is no point of doing acceptance, right? If the requests itself are not there, then you exit safely. But one day your program is running, suddenly passwords were like expired. So when password expired also, you cannot do anything. Then also you need to exit it. So when password expired, it is not intentionally. It is like problem, right? So that's why we exit with a sys.exit of -1. So hope you understood in which case why that. Okay, what is the difference between this break and the sys.exit? Break is designed to exit from the current loop, right? So means after break also we have written a lot of statements. Everything is working. Then what is the concept of a sys.exit? If you do the sys.exit, it will exit the entire program itself. You see, after this logic, I wrote this next statement. Generally, next statement is executing till now, right? After all you're done. But the moment sys.exit is encountered, that will be the last statement of execution. No matter whether you do 0 or 1, but sys.exit is the last. Now, hope you understood the difference. So break is to break the complete loop. Continue is to skip the current loop. Pass is will not do anything. It is like a to do. And sys.exit will exit the script execution, the entire script execution. And if you want me to repeat the same thing for a for loops, I can do, but like the same concept will be there. So if I repeat again for the same concept, say like I will take some values, and for that values I want to do a for loop. Generally, for loop, if you want to apply, we need to apply on a finite values, right? Either we need to have a range or something. I took a list of some people. So I have some students. For these students, I want to loop. So initially, if I want to check for the importance of break, I am doing like this. Whenever I am parsing, the moment the student name is Bhavana, it should break. In other cases, it should print. So when it is parsing from left to right, so you see what will happen. Clear and Python J so and so. First Akram and Trisha came. The moment Bhavana came, it was broken. So that is how this works. Whereas how the continue will work, continue will skip a value, right? You can write any condition. So the name starts with something or like anything you can write. So whatever the condition was met, if the condition was met, so you want to continue. So continue means you don't want to skip the current line. So that's the reason Bhavana will not come in the outputs in the continuous. In the same lines, if you want to see the importance of pass, so instead of that, you can write anything. So instead of a continue, I repeat with a continue. And pass if I write, it will not execute anything. And one more question. So one of the person was asking this question. What will happen if you write a print statement after the pass? So will it execute any print statement if it is written after pass? Logically tell me, pass will not do anything. If anything is there after pass, if it is part of the structure, it should execute, right? If you execute it, did you see this line is executing? So what I'm trying to say, pass is just a line. So if it is part of a structure, it will make the structure intact, that's it. If you have three statements, between that, if let's say I have three prints, say one print is there. If the same print statement is there, if I have some print statement, in between that, I can have some passes. It doesn't mean that I should have only one pass. I can have any number of passes. I have a pass. I have a pass. I have a pass. I have a pass. And not just one pass. I can have any number of passes. So pass is just a statement. It doesn't mean where it is there, how it is there. It will have its own essence. So whenever we need a structure, empty structure, generally we use pass. That's it. Pass itself is like a placeholder. It makes no difference whether it is present or not. Hope you all understood now what is a pass exactly and what is its importance. And the last point to say, so as we have seen about the sys.exit. So the moment sys.exit is encountered, everything else will be stopped. As you know, that's the last statement to execute. So maybe like, I'll place all the passes down and then place it. You can see that. So this is how these four things will execute, which are like very much needed for you. So based upon that, you can evaluate the things on your own and do. So, and I want to give a small assignment for you to calculate the average of numbers. So you can do an average of the numbers using while loop itself. So users can give any number. So take a value and get the averages, some binary operations, whatnot. You can do anything for that matter, I guess. I think now you got enough knowledge of doing all these things. Next, further, if I go, the last option after knowing the loops also, a recent one is something called as a Walrus. This is very interesting. Recently came, so Walrus Operator. So what is this Walrus Operator? How it can help you? It's very new, very recently it came. First, to understand this operator, let me give you a simple usage. If I can go on, where am I? Yeah, let me create a example.ipynb. Let us go back to the ipynb, means Jupyter notebooks. So first I need to take the kernel. First, we need to understand about this Walrus operator. This Walrus operator is also called as assignment expression. I think for the first time you are hearing a new thing. So this is Walrus operator. It was introduced in 3.8. Right now the version is like 3.11, I guess. So 3.12 is coming here too. What is this assignment expression? How it helps us? So traditionally, whenever you have some value, let's say like this, value 1 is equal to 10, and you'd say value 1 is equal to 10. This is a very simple example, right? You create a variable and you print it. So there is no big difference. Means when you're printing, you are using it. But if you want to use with Walrus operator, I can just do like this. Means I am creating the variable and using also at the same time. It is not just for printing, I'm saying. So you are creating and using also at the same time. That's a point. So let me give you one more example. So same like in the same way. If I say like, so val1 is equal to 100. So if I do like, val2 is equal to val1. So like this we have. In the same fashion, if I want to do the same thing similarly, so I can do like val2 is equal to val1 colon equal to 100. Means instead of you doing it in a 2 lines, you can do in 1 line. That's the point I am saying. That's the example I want to bring to your notice. Or let me give you one more example. Say like, you see in this example, first you're defining a variable called as number1 is equal to 123, and then number1 percentile 2, you are checking. So in this particular case, this number1 is used only for this condition. In that case, you can define and use there itself, right? So for that particular purpose, we can do with this kind of things also. Instead of doing like this, we can also do like this. What I'm doing, number1 colon equal to 123. So percentile 2 means it will as first create the value. For that value, it will do the operation. So sometimes we need to define the variable, and the variable will be having a usage only temporarily. In that case, we can do like this. I repeat again, one more example. You see, in this case, so generally we are getting the values from runtime, right? Number1 is equal to getting the value, converting to integer. You are checking. So this number1 is used only for this condition. So in this case, you define and do. So does it mean that, this number1 can't be used outside? Yes, we can use it. So it is kind of like creating and using at the same time. That's what is called as assignment expression. Assignment also happens, expression also happens, both at the same time. Any doubt till now? Fine. So next, if I go for one more example, say I have one example like this. If I see, I have numbers, a is equal to some values. So n is equal to length of a. So based upon that, I want to do. Means a is a list. Based upon the length, I want to do something. So let the list be like this. But I am doing the condition based upon the length, right? The length is n. That n value, I can just get directly here. You see, whenever the value I want to create, that I want to create in braces. Means, the PEMDAS logic, right? First things which in the braces will execute first. So that's the reason we need to do like this. First, as the highlighted, the length will be calculated and stored in it. And based upon that, the value will be taken. So whenever you have like two things needed at the same time, we can go like this. So in the same fashion, if I go another for like one more example, yeah, with Walrus operator, many things I can do like this. So if I think some of the example to explain, you didn't walk through certain things at this stage. So when you're going over a period of time, I'll explain all the things whenever their need is there. So, but this is how it will work. But if you want to, yeah, this is one more example. As we have already worked on the loops, this is a good example. You see, so previously also showed a condition while true, you come inside, the command is equal to user gives something. If the user gives exit, then you want to break. In other case, you want to print whatever the user has given. This is a simple logic you have. If I want to repeat the same thing, use a Walrus operator, I can define like this. So command is colon equal to so and so. So based upon that, we can do. Means, so same like that. In the previous example also, we have written our own logic for the number guessing game. So there also we have written, right? So we have taken a choice separately, and we have done like this. So there itself I can write using the expression. So like that, there are different options we can have to do this thing. So these are all about the Walrus operator, that what all we can do. So it is kind of like writing the command and doing the condition, using it both at the same time. So that's the point. So we can stop here. Yeah, see here again. Now coming to the concept of exceptions. Exception means what? So literal meaning of exception means to accept something. Even something is wrong also, you are accepting it. So generally when the things will be wrong, so everyone tries to write a code which don't have an errors. So is it means like if the code is error that if there are errors in the code also you are accepting, or if there is some problem in the code that you are accepting? Means there is a problem in the code that you are accepting. What kind of problems which will happen which you want to accept? Means like, so just imagine the simple cases I told. You wrote a code for scraping a Facebook, and if there are a friend request, you need to accept. But suddenly, so on a particular day, your password was expired. There is nothing wrong with your code. The code is working perfectly. But this is a odd case where the password was expired. If you know how to handle it, if the password was expired, in that case, instead of throwing a big error message, it will handle that. What is this handling concept? Just imagine you open an Android app or like anything. So if something happened, you got like a big error message. Will you be happy as an end user? Or if it just gives a small message that network connectivity is very poor, which one the user will be happy? Means user is not saying that you will give a perfect software to me or perfect program to me. If there are problems, how you are handling? So you should not give a big error message. So we should say in a user understandable messages when problem comes. This is the whole point of exception handling. So in this concept, you need to understand the difference between an ordinary error and an exception. Error can be of different ways. It can be a syntax error, means if the code itself is not clear, correctly written as per the Python syntax, then the code itself will not run. Anyhow, as you are daily seeing, you will understand the syntax errors, how to handle it. Okay, when program runs, the remaining errors comes. That other one, exception errors, means you write a code which will be perfect as you wish. You write unit tests, everything. But I told some odd cases will come, like password expired, or someone don't have an access, or your access was removed, or something else which are not in your control. So you want user to enter some numbers, but they enter some alphabets, or like someone is doing injection attacks. So things are beyond your control, how you are handling. And apart from that, there are something called as logical errors, which you don't want to touch at this moment. In the next chapter, there is something called as debugging. We will discuss there. So now our focus is mostly on this exception handling. Okay, in total, Python supports different kinds of exceptions. So for handling this, so if I go to this, this URL, so they helped me understand a lot of concepts. If you go to this URL, this is a Python library actually. So built-in exceptions concept. What are the exceptions and all this information, everything they have written. So to summarize all this information of what all they have given, so I made a list. These are the total kinds of exceptions supported. First one is the base exception. Under the base exception, there is a base exception group. So generator exit, keyboard error, interrupt error, sys.exit. And lastly, there is an exception. Under the exception only, you have all the basic exceptions that you are seeing right now. So from starting till date, you have done a lot of Python coding practice. Over a period of time, don't you think like what are the error that your hand occurred were all in this only? Be it the zero division error, be it the arithmetic error, so be it the name error. when you have undefined. So, so down the line, you will learn about different kinds of errors. So these are all the different exceptions. Not only the errors, there is something called as warnings. Means, sir, can we handle warnings also? Yes. In the warnings also, we have seen syntax warnings. Hope you remember when you use is operator with ordinary numbers, you got a warning, right? So like that, there are different kinds of warnings also. And sir, are these the only one? No. So when you go ahead with the different modules, those modules also will give some exceptions. If you go to the request module, request is the most common Python module which is used. And if I go to this request module, even this request module is one of them. If I go here and in the request module also, if I say like, exceptions, if I say, means I am telling like in this module, what kind of exceptions are there. So why I'm picking this request module means this is the most commonly known. So like that, there are other things also. Means they also will support some kind of exceptions. Invalid JSON error, invalid JSON decoder error, HTTP error, like that. So they also support it. Means in the practical world, there will be a lot of exceptions. And in fact, you will create your own exceptions also down the line. So I will tell you how to do that out too. So there are different kinds of exceptions we can handle. So now we understood the entire eternity of exceptions, how these exceptions are there, and how the things are working. Now the last step to understand here is in terms of how these exceptions are actually there and how to work with it. So now to understand these exceptions, how to implement, in exceptions, in totality, there will be 4 blocks. So 4 blocks of exceptions will be there. So to see, you see, there will be 4 blocks. Try, except, else, and finally. What are these blocks? How they are executing? So, and when during different phases, things will execute differently. First of all, let's see how an exception occurs. Whenever you do any mistake, exception occurs, right? Of course, syntax error is different, but logic error, so these errors are different, right? Syntax means if your code itself is not correct, that's different. If I 10 by 0, syntactically it is correct, but it is not correct, right? 0 digit error occurred. If I tell like, 10 divided by same 0 as a string, if I do, now you see what happened? Slightly different. You got a type error. In the same example, if I do like this, instead of this, if I do like a number, the same thing, I got like a name error. You see, slight changes in the logic, I got different kinds of exceptions. And 0 digit error, here is type error, here is name error. Like that, I got different kinds of errors. Okay, different based upon different situations, you get like different exceptions. Then like how to handle these exceptions and in which case we need to go in which way. To understand further, so we can go ahead and work on one of the exceptions. Say like the first exception is 10 by 0. Generally, as a common man, we can better remember the 0 digit errors a lot. How to handle this one? So to understand this, okay, there are like 4 blocks: try, pass, except. You asked, right? What is the uses of pass? Else, and finally. So these were like the 4 blocks in the code. To ensure that these 4 blocks are executed, I have written like this. This is how a typical trials blocks will be there. So in which case, what we need to place? Whatever the logic that you are thinking should be like, tested. It doesn't mean that the logic will every time throw an error. So whatever you have a doubt, so the doubt logic we need to place here. So exception handling messages. So exception handling messages whenever you are doing, and it doesn't mean that every time we'll get an exception, right? So when logic to execute, when no exception. And similarly, it doesn't mean the only exception messages. We can also write like, logic to execute when there is exception. When exception is there, what logic to execute? That also we can write. And finally, it's like a placeholder. Executes both times. Means when there is an exception also it executes. Whenever there is an exception, no exception also it executes. I will tell you its importance afterwards, but slightly. And also this point in the process, if you see, it doesn't mean that every time we need to have this else blocks. So these are not mandatory every time. These else and finally blocks are optional. If you don't write also, it will work. If you don't write also, it works. No, okay, sir. So theory apart, coming back to the logic. What are the doubt you have? Like, 1 by 0 I have. So that 1 by 0 if I write, so now if you see in this case, what will happen? So it will execute. So you can write like, what is the message? So don't divide by 0. Don't divide by 0. So this is how it works. So similarly, if I go further, so don't divide by 0, I'm saying. How can I know that the message is only 0 division error? I should not predict, right? What if this value is coming in runtime and the user is giving not a 10 but something else they give? So some other error can also come, right? So instead of we being sure, so you can also write something called as exception. If you write exception, the advantage is that you can get the exception message also. In Python 2, there used to be comma, but like in Python 3, there is as some variable if I give. I can get the exception message. Instead of I saying like 0 division by error, I can say like, so exception message. So EX if I say, if I execute, I get like 0 division by 0. So as I have written, don't divide by 0. It is giving division by 0. How you are getting? You see, when you did a 0 division, you got a error message, exception type, and also the exception message, right? That message you are getting. And this is where you will understand the difference between STR and REPR. So to understand further, I give that STR of EX and print of REPR of EX. Observe the difference, you will understand. If you just print also, it will give STR. If you do STR also, you get the same thing, just error message. But when you do a REPR, you get the raw representation of the string. For every string, if you do REPR, it will give the raw representation. It includes the error type and also message together. So that's the reason most of the time I use REPR so that I will know what exactly happened, what is the things. So this is how it works. With this, so we can kind of like stop.